Hello, everybody. Can everybody hear me? It's fine? Good? Awesome. Very cool. So thank you for coming to the session. In this session, we'll go over the idea of making a very simple and cheap Solr cluster with the latest Solr technology available. Mind you, this is not aimed toward crazy performance Hadoop thing. This is just to make something that is fairly scalable at the lowest price possible with the least amount of effort. All right? Before we go into the presentation, there's a book giveaway, as you know now. I decided to make it a little different. For this book giveaway, I hid a quote somewhere in my slides. So the first one to email me with where that quote came from at the end of the session will actually get the book. All right? Or you can shout as soon as the session is over. So beware for that quote. All right. So who am I? What do we do? And how did we came across doing Solr clusters? So basically, I'm the CTO and co-founder of Searchbox. Searchbox is a small startup company in Switzerland. And what we do is we try to provide search as a services. At the end of the day is we end up creating search engines on demand for all of our clients. So you can see it could be quite demanding to create one search engine for your company, while we create search engine on a daily basis for all of our clients. In order to be able to make that company work, we need to very much master how to make a cloud, how to make it available, and how to scale that cloud. Scale in multiple factors. We, of course, when we provide a Solr search engine, we must have a high availability. Every client needs to have a certain redundancy. They need to sustain a large amount of query per second. And when I say large amount of query per second, I'm not talking about 4 million query per second. Most of our clients are within the 200, 300 range of QPS max during peak hours. We also need to provide them with monitoring, make sure that everything works, because they delegate all the search expertise to us. And of course, we need to have something that is entirely recoverable. All right? On top of that, we need to have index provisioning. We need to be able to create collection like this. When you sign up, you need to have your collection readily available. To do that, we need to make sure that our cluster is always of the right size, that we have the right amount of machines to supply newcomers. We also need to make sure that our nodes within the cluster are fairly well distributed. We'll get into these details in a moment. So there's two stories about it. And today I'm only going to tell one side of the story. It's not before 4.x. Before 4.x, doing a Solr cluster was pretty daunting. Okay, you had a master-slave paradigm. You needed to manually select which one is the master, which one is the slave, which led to a custom routing. If you have multiple collections, you need to route your traffic to the right machine that has the right collection. Otherwise, you get a 404 collection not found, or you get some type of errors. And making our index provisioning turns out to be really hard, because every time we create a new collection for a new client, we needed to create a new master, the new slave that goes along with it, update all our load balancers so that the traffic goes to the right machines. It was a nightmare, and my company would never worked with such a design. So, first thing is, thank you very much to the Solr Cloud team. I tried to spot them out one by one to personally thank them. They did an amazing job. They did a very, very good job. And today, my goal is to show you how their job is making it possible to run a very simple cluster in a cost-effective manner. The three major points of the 4.x branch is, first of all, there's no master, no slaves. Everything that you put in your cluster is simply a node. All right? It's the WAR package of Solr, ship it, and that's it. No more hassle. There's automatic routing. Whether your query gets to somewhere, your load balancer, or even a node, or even ZK, or anything like this, the cluster will find its way to answer your request with the right node. You will not get a 404 anymore if you hit the wrong node. Simplification of the traffic routing, incredible. And then the last point, and for us the most important point, is provisioning new collections is simple. It's just 2 API calls like this, and we have a new client that's capable of running on our cluster. All right, very good. And we didn't do any of these. Huh? This is Solr entirely. So let's go a little bit into Solr Cloud. What is it? So first of all, I wanted to say that Solr Cloud is nothing else but Solr. All right, there's a big mystification about it. The mailing lists are asking a lot of questions about what is Solr Cloud. It's a plain old Solr. It uses Lucene 4.x, it uses the same schema, uses the same Solr config, and the majority of the plugins that you are using in any Solr instance will work with Solr Cloud. There's one exception. Each plugin that has a direct access to an index reader will not work out of the box. There will need to be a small rewrite on that. The major change in Solr Cloud is a separation of concern. Separation of concern between the configuration of your collection and your cluster, the state of that cluster, and the nodes that actually do the work. This is done through Zookeeper. I'm pretty sure everybody heard about Zookeeper when you get to Solr Cloud. Zookeeper is nothing else but a fairly brilliant registry. Think of it as a shelf into which you put all the stuff that you need. You can save files there, you can save pretty much everything you need. The two things that are of interest to us is that you save your collection configuration. That is, everything that is in your /conf directory, just put it in Zookeeper. All right? The same way as it used to be into your Solr directory, Solr/conf, and so on. So you have your schema.xml, you have your Solr config, and so on. The other type of configuration that is centrally saved into Zookeeper is the status, the structure of your collection, namely the number of shards that you want in that collection and its replication factor. We'll get into details about these two. They have a drastic impact on your cluster. We'll get into that a little bit later again. Now, the major advantage of Solr Cloud is their node. A node is trashable. Key point is it is disposable. Why? Because when a node joins the cluster, it registers to Zookeeper, which is your centralized configuration. Zookeeper then assigns it whatever work it has to do. The node doesn't need to know anything about that beforehand. So its configuration is one line. It's where is Zookeeper? That's it. Then the node has two behavior. Either it's a leader or a replica. I'm not going to go into the details of these two roles. Think master-slave. It's pretty much the same idea. But in terms of usability, it doesn't change anything for you. These nodes, when they join the cluster, they need to get the data of the collection that they're supposed to work with. Solr Cloud has made a tremendous change. The data is not always taken from scratch with replication. There's a new peer discovery so that each of the nodes participating in the same shard of the same collection can contribute to providing that new node with data. Speeds up the recovery time and makes it way more robust. Keynote is these nodes, think very much of them as disposable nodes. Disposable nodes entails simplification. Don't bother looting up EBS storage or things like this to store your data. Put everything in ephemeral. Much less work to maintain, much easier to deploy, much lower time to deploy. So that's for the nodes. Then there's a very, very interesting thing. It's automatic routing. Automatic routing is you send a request to your cluster, and you do get results back. Doesn't matter who got the request. If it's behind a load balancer, you will always get your result back. There's a distinction now in Solr Cloud between a smart client and a non-smart client. A smart client will require a connection to Zookeeper so that it knows beforehand which node to do the request to. Among the smart clients, there's SolrJ. So if you use the SolrJ client library of Solr.4, you have a smart client, and you can gain from that feature. A short note about automatic routing is if you have the choice to use a smart client, do. Otherwise, you will generate a lot more traffic in between your node. What happens basically is when you have a request that comes to the load balancer distributes it to any node, do a round robin. The node figures out whether it can satisfy the request. If not, it will ask Zookeeper which node can and forward it to so on and then come back. Keep in mind, traffic usage, network traffic. Another key feature about Solr Cloud is its collection API. At the end of the day, this is the only thing that you should be using. No more cores, pure collection. Collection is an abstraction level, all right? When you have your index that is distributed among multiple machines, then you cannot query a core. You need to query something that knows how to get the totality of your information. So basically, an index, or whatever you work with, is a collection. A collection is a set of shards. Okay, this is very, very straightforward for anyone that used Solr. And a shard is a set of cores. All right. Why is this important? It is important because they stack up nicely. The collection is what you configure. It is what you work with. The shard is the materialization of that collection. Okay? You can split a collection into multiple shards, but you don't have to. Then each shard is actually materialized inside of a core. So of course, you can replicate the number of cores per given shards. And each core lives on a node. They can be multiple cores on one node. Okay. First, I wanted to make a pyramid, but then the pyramid on my slide looked very, very bad. So I decided to stack it this way. Very interesting point about this is each of these levels behaves as a scaling factor. If you have a very large collection, then you might have a scaling factor at the shard level. Okay? Then you see there's the num_shard parameters of your collection. If you need to have a higher throughput, a higher query per second, you might want to increase the number of cores, each representing a shard. This is your replication factor. And then for us, for the provisioning, we need to know how many nodes we have so that we can know how many cores we have, so that we know how many shards we can make and how many collections we can provide. Thankfully, again, Zookeeper provides you with an exact number of how many live nodes does it see available. This is, if you look at the Zookeeper tree, you will see the live nodes. Why? Because when a Solr instance is launched, it registers itself with an ephemeral node. An ephemeral node is a node that exists in Zookeeper for the time that the instance is alive. If the instance dies, it dies. So going back to the high availability on Solr Cloud. For redundancy, well, let's just add some more replicas. Okay? We can make these replicas pretty cheap now because we're using ephemeral storage and we just launch them up in the air. Cool. Sustained QPS. Well, if by redundancy we don't have a high enough throughput, we can always add replicas. If your data set is too large, you can always shard it. There's a very much welcome feature in the next release of Solr Cloud, which is shard splitting. So you can start with one shard. You realize this is way too big for your machine and you don't get the throughput that you want. You can always split it later on. Monitoring, very, very important. And we'll get back to that specific part in a moment. Monitoring, ZK gives you two very important things. One is this cluster status. Cluster status tells you the state of a collection materialized in each of the shard and the cores of your cluster, whether it's down, whether it's up, and so on. It also tells you which are the live nodes. Why do I put live nodes here? Because it's pretty easy to see which machine are up or down. If a machine is up but not registered in Zookeeper, it won't participate in your cluster. So the only point that you know where machines are being used is from Zookeeper. In terms of recovery, well, there's the peer recovery that makes it a bit faster than fully replicated. And of course, there's the long legacy, super tested, and we know it works, replication handler. At the end of the day, all of this has made it so that scalability is based on one factor only, adding new nodes. Once your setup of your cluster is good, simply by adding new nodes, you will have a high scalability. So it comes to a very, very great question. Whoops. How do we design, how do we size, how do we make the Solr Cloud the right size for what we need? The key metrics are, first of all, know your collection. Its size and its complexity. How many documents, what size of document, how many fields, and so on and so on. Why? Because this will have an entailment on the GVM requirement. How much RAM do you need to actually perform? Because you know, Solr does not like one thing is being stored on RAM. So if you don't supply it the RAM that it needs, then you will have very, very poor performance. So GVM requirement has an entailment on node requirement. How many GVMs can I run on a given node so that it can execute whatever it has to do? All right? And again, this is a loop. Why? Because the node has an entailment on how many collections can I run on the cluster that I have. Good? It's a very bit fuzzy, but we'll try to clarify it a little bit. All right, let's take a pragmatic example. PubMed. PubMed is a medical publication in the United States. It's about 12 million documents of abstract, publicly available. All you have to do is ask the government and they give it to you. 12 million documents. We index 7 fields. For example, there's 2 fields that are using term frequency vectors, 3 sorted field and 5 stored field. It's pretty common. It's not a small index. It's not a large index. It's a medium index that you could find pretty much in any intranet network. All right. Now, one thing about that index: how do we materialize it into the cloud? Well, small note about sharding. Okay. Sharding is quote quote the magic sauce of web scale. Well, yes and no. Let's look at the RAM requirement for a shard. If you're running 1 shard, you have X amount of RAM requirement, okay? Running twice the amount of shard doesn't divide it by 2, and so on, and so on, and so on. If you know about the inner workings of Solr, it's pretty straightforward. There's the dictionary and the terms that you always need to have on your inverse lookup. So you need to find the sweet spot between the amount of shards that you need and the size of JVMs that you're willing to put into your cluster. If you want to put 6 gig JVMs all over the place, fine, it's just going to be more expensive. A 3 gigabyte JVM might be a bit cheaper. All right, so let's go with a 3 gigabyte JVM. Same effect on the disk, okay? So the disk is the same thing. Put 2 shards, don't have half the disk. Now there's one extra feature about the disk that everybody needs to keep in mind. When optimizing, when doing any type of optimization within your shard, you will need a much larger amount of what the index size actually is. So plan big. Take the upper bound. All right, so this is pretty much our configuration. So we have this PubMed data set, and we decide to put it into that configuration. 3 shards, replication factor of 2, so if one of my machine comes down, I can spawn a new machine, and then I can replicate into that machine. That's pretty cool. If you're very conservative, go with the replication factor of 3. Here it's up to you. I mean, you can go with the replication factor of 1 and use a backup by simply using the replication handler of your cloud. Works as well. Whatever floats your boat. The idea is to be as cheap as possible and as readily available as possible. Okay, we've seen from the figures before, this index should be running in about GVM RAM, 3 gigabyte of RAM, and 10 gigabyte of disk. All right, fine. That gives us the idea on how to size the cores that we want to supply into our index. Okay. Now, mental note, we supply cores for indexes that we don't know of. So this is why this is a heuristic experience. You will supply cores that are too large or too small, or you know exactly the collection that you're going to maintain. In our case, we don't know. So we need to decide on a size of a shard that is fixed so that we can control the scalability of our cluster. So because we don't want to starve the resource on the node, okay, they all need to be able to not overlap on CPU and RAM. We settle for something fairly large that can take the shard of the PubMed. 3 gigabyte of RAM is a requirement, and 60 gig of disk. Okay? We know that this is the minimum requirement for 1 core to run in our cluster. Very cool. So now, let's actually put that cluster up. Let's materialize it. All right. We can put it on Amazon. Hey, why not? So I've put a table with the different type of Amazon's instances that you have. All right, given their prices, how many nodes can they support? Okay, nodes by core. Minimum, we need 6. Why 6? Because we have 3 shards, 2 replicates, that's 6. And depending on the machine that we have, we see that we have a much larger cluster available for scaling. So for example, if we take M2 2x large, we'll fit PubMed on that with our 6 nodes, 6 requirements. So we have a minimum of 6 machines, 6 instances running, but we have 66 cores available. So we can fit a lot more other collections into that same cluster without competing for resources. That is, without competing for RAM and disk. I'll come to the CPU in a second again. Understood? One key point to take away is that the larger you go with the higher hardware or the higher nodes for your cluster, the lower your price per core gets. So if you're in the business of supplying a lot of different cores for a lot of different collections, go big, because you can reuse. Now, all that is fun game. You need to monitor this. You need to monitor for a couple things. You need to monitor it for balancing, making sure that you don't compete for CPU, making sure that your nodes are behaving, making sure that you have the room to make new collections. Solr monitoring, perfect. We have cluster state.json that's given to you by Zookeeper. This tells you at any given time the status of your collections within the cluster. Okay, you can compute, for example, how many replicates does it has? Are there some missing replicates for collections? Lots of information available in there. Again, live nodes. I stress again, use the live nodes of Zookeeper, because otherwise you will end up having machines that you believe are working within your cluster while they're not. And then on top of that, you need to add some monitoring about your nodes. That is not done neither by Solr nor by Zookeeper. You need to know if your nodes are actually working, if they're overworked, okay? Because it's one thing to fit them into memory and RAM, but we have never talked about CPU. CPU is not one thing that you can anticipate. You don't know it. So you will need to monitor your nodes to see if there are competing resources for CPU. You need to know that if you put multiple cores on one node, which core are highly CPU demanding. If you have two cores that are highly CPU demanding on the same node, you will lower the performance of your Solr cluster. You also need to know which collections are demanding. Now, the easiest way to know which collections are demanding is don't even bother to go down to the Solr core or to the Solr install, whatnot. Look at the log of your load balancers. Simply, as simple as this. It's basic analytics. Basic analytics will get you very, very far into making the best out of the available cores that you have for your cluster. Small note about provisioning, all right? Two types of provisioning again. When you boot up, when you put all your nodes into your cluster, if you have more nodes that is required by the state of your cluster, they'll just become standby. They'll wait here until ZK actually assigns them to do something. These are standby nodes, all right? You always need to have a number of standby nodes available to be within the HA, high availability. So monitor the number of standby nodes that you have at any given time in your Solr cluster. Now, node addition. This is the self-healing part. At any given time, we need to know whether or not we are getting short of standby nodes, or if in the event of a new collection, you have a new customer sign up, or you have the need of a new collection, we need to make sure that at any of these given times, we have the sufficient number of nodes available to support the new cores. Okay, one collection makes a shard, makes multiple cores. Keep that square pyramid in mind. Okay, so this is very simple to do. Just make a cron. It's a cron that checks on the cluster congestion. Every minute, check out how many nodes are used, how many nodes are still present in your live nodes, and if it spawns your entire cluster. And then you can automatically spawn new nodes per need. We all know it's pretty easy to generate Amazon instance with one API call. So this can run on the bash script on its side, and you never have to worry about it again. All right. Small conclusion is, Solr Cloud it feels at the beginning like juggling. Okay, there's lots of parts. Remember that loop. Your collection makes shards, that makes core, that makes node, that makes collections, and so on and so on. So at the beginning, it's hard to get your grasp on it. One thing that you need to take for granted is there will always be some magic left. You have to work with it. It's fine. The way they do peer discovery is amazing. Does it work? Yes. What you need to do is, instead of understanding that magic, you need to understand your metrics. To take an example of the PubMed example before, if we have one node that goes down and we supply a new node to the cluster, from 0 to actually participating into the cluster, a core takes 7 minutes. This is a key metric that one needs to know. It will be different for each collection. It'll be different for each cluster. It depends on your network. It depends on the type of I/O that you have on your Amazon instance. It depends on so many variables that at the end of the day, you need to test it. You need to test it again. You need to test it some more. And you need to test it again and again and again until you have these metrics so that you feel comfortable. Otherwise, it will be overwhelming. Otherwise, you will lose core. The replication factor will not be high enough, or your responding time will be too big. So it's juggling. By testing it, you get practice. And by practicing, you'll master your Solr cloud. Of course, when it fails, it's like juggling. Huh? You lose your balls. So never, never get there. All right. Now this is for the Lucene community. What would be really, really, really cool in the next release would be for ZK to itself balance the core on the available nodes. For the moment, we need to do that. We monitor the node load. We monitor the collection load. Okay, so we have heuristic that says, okay, this core, instead of being on this machine, because it competes with the CPU for that core, which are heavily used, we're going to move that core away to that node, because that node has another client that does 2 queries per second. So we need to find a way, we need to have a very standard way to migrate nodes over without disrupting the entire work of the cluster. How could we do that? One wish feature, it has been done. It's not part of the collection API, but I know it exists, is to have cores as standby. Standby would be the same thing as a replicate, okay, but they wouldn't be live. They don't serve requests, and they would update themselves maybe every 5 minutes, every 10 minutes, or something like this, and then shutting themselves down, so they don't compete for resources. If we had this, we could lower the replication factor. In our own cloud, we run a replication factor of 3. We could lower the replication factor and have some of these standby nodes for all of the shards of our cloud. All right, so far? Good. So, you want to get into Solr Cloud? Awesome. My recommendation is, if you use Solr 4.x, don't use it as a standalone. Get in the habit of using it as a Solr Cloud directly. It comes at a cost. It's a fast pace changing. The amount of work done by Lucid in that specific area is tremendous. So there's a requirement. Don't even try Solr Cloud if you're not part of the Solr user mailing list. And I won't stress that enough, is the pace is so fast going that some of the information in those slides are outdated because I did them 2 weeks ago. Updated the slide then. The mine gold is in the mailing list. They're very responsive. There's a large amount of information. Next other type of information is you have blogs and feeds. We blog a lot about this simply because this is our backend, pretty much. So it's an interesting backend. It's an interesting way to scale at the lowest amount of price with disposable hardware. If I lose half of my nodes today, I get text messages, but I really don't care. This is cool. And of course, if you have any questions, or if you want any more information, or if you want an account on our Solr Cloud and try to crash it down, please don't. Send us an email. Yes? Okay. The one thing that you really don't want to happen in your cluster is resource contention. You don't want it. The one thing that's really, really bad. So the question is for everybody, when it fails, you lose your balls. When it goes really, really bad, you end up with, for example, some replicates that don't have the same number of documents than a shard, that their leader, okay, and you don't really know why. That might be one failure that you don't understand how it happened, but it happened. The majority of the cases when a huge failure happens is when there are not enough resources to supply the throughput of the cluster. It could be I/O resource, could be network resource. A Solr cluster instance is much more demanding in terms of network than a Solr standalone, because the leader talks to all of its replicates, they all talk to ZK, and so on, so on, so on. So you have to, when I say know your metrics, I'm not kidding. This is the, if you're in the clear with your metrics, if you're in the clear with IF top is your best friend, okay, for example, IO top is your second best friend. If you know your metrics, you will be fine. Trust Solr and it'll do its thing good. If you try to constrive it too much, maybe to gain a few bucks or because you don't have enough hardware, you will end up in the bad place. Does that answer your question?
Yes.
Awesome. In the meantime, what happened when a leader falls down? Well, this is all part of Solr Cloud. It's part of that magic that I say you have to take for granted at some point. Solr Cloud comes with the leader election algorithms. So basically what happened is all of the Solr will start talking together to figure out which one has the latest version of the index and will elect that one as a leader. So you have a leader overtake at any given time. So if a leader falls down, you will have, there's a new leader that will come up. You will also not lose any data if there is data indexed during that, that time period because of a commit transaction log. Sorry for that. For more information on that, I would refer to the mailing list, because then it gets into that magic that's really hard to understand. Yes, in the back. Your question is, how much do I leave for the OS? Marginally nothing. We leave very, very little to the OS. This is a personal choice. Some people, especially with the 4.0 branches, advise to leave more RAM for the OS because of the usage of caches, OS cache. So it probably would be a good idea to leave a significant amount of the RAM to the OS. Again, I don't have a set answer for that, but you raise a very good point. Rule of thumb is we leave at least 700 megs for the OS. Okay, so the question is in here. Recommendation is to use the smart client for decreasing the amount of network activity within your Solr cluster. But then later on, I recommend looking at your log of the load balancer in order to infer some metric on the collection usage. Well, it's a simple matter of fact. With the smart client, you will only get so far. So if you have actually implemented your entire application using Solr J, yes, the load balancer is useless. But then you have the end on the application, so I'm pretty sure you do generate log on your application level, which could replace the load balancer. Because we provide a search engine for other people, for third-party people, we have our own interface that uses Zookeeper and smart clients, but all of our clients are mainly using a Solr endpoint, which is itself a load balancer for the entire cluster behind. So the idea is, of course, if you use a load balancer, you have valuable information in that load balancer. If not, make it available from your Solr J client or your application. Does that answer your question?
Yes.
So if we have a customer whose index keeps on growing, how do we fit them in the picture? Well, we fit them with our shard paradigm. So if they go and they need more than 3 GB at any given time, then we'll split them. We split their index into 2 shards. So then we have 2 times 3 GB. Then again, if these 2 shards grow too big, we split again. And then we end up with 4, and so on and so on and so on. The question is about how do you make Zookeeper not being a single point of failure, pretty much. To this, I followed Zookeeper's documentation, and I'm pretty happy with what I have. I'm not a Zookeeper expert. There are 2 things to take into requirement. Zookeeper is not resource intensive, okay? But it needs to be with the lowest amount of latency possible. Each latency in Zookeeper will will propagate into your entire cluster. So you want small hardware maybe, but you want it to be dedicated to that specific task. The other thing is when you make a Zookeeper quorum, a quorum is an assemble of multiple Zookeepers, so if there's one that fails, the other can take over. there are multiple ways to actually architect your quorum. You can architect your quorum in multi-AZ, so you have a quorum in one zone and a quorum in another zone, so you're sure that if even the entire data center goes down, you still have the other one. Rule of thumb again is a quorum is a minimum of 3 machines. These 3 machines needs to be on the same LAN. They need to be on a very, very fast connection. If you make a quorum, so you have a master quorum and slave quorums and so on and so on, if you make a quorum across the entire world, its update time might have performance issues into your Solr cluster. Does that answer your question? Yeah. I'm sorry, pretty much my answer is look at the documentation. Yes? Yeah. First question is, what happens when you lose a machine? Well, there's a couple scenarios. When you lose a machine, you lose the core that are on that machine. You only lose, yeah, if these cores are representing of a shard and your collection has multiple shards, you only lose a core of a shard. If you lose all cores of your shard, you're in deep trouble. Yeah. Data is lost. Yeah. That's it. This is why you have to be very careful about your replication factor and how long does it take to go from 0 to working core that replicates a given shard. 7 minutes for the PubMed, you need to know how long it will take for your own data. Why? Because this replication factor, all these replicas, are not on the same machine. Okay? You saw on the grid before, we have a minimum of 6 machines for that given collection. So make sure that these cores are not on the same machine. If you lose one, you should have a replication factor. If your replication time from 0 to actively being part of the Solr cloud is too big, augment your replication factor. So that you will have more nodes, yes, but then 2 can go down, and your shard is still provisioned. So the question is, in case of a drastic event and you lose all of your machine all of a sudden, what happens? Well, there's 2 answers to that. Either we file in for bankruptcy. That's one way to do it. The other way is you can still replicate whatever you have in your Solr cloud, because the replication handler is available from any node, into a distant backup. I would advise to do that rather than going into much more complex, let's put EBS volumes and make sure that the EBS are staying in the case of event of a power outage. Basically, my recommendation is don't go with hard hardware, okay? Go with simple hardware, and if you need to add an additional backup, just use the replication handler. Thank you very much, guys.